introduction. I'm really excited to be with you today. Thank you, everyone. Today we're going to talk about generative AI, and I believe this is a very, very important and hot topic these days. So let's get started. So as you can see from this Gartner report recently released, they are talking about the three emerging technologies that will guide your business decisions across these four quarters. And we can see that AI is actually spread everywhere in each quarter. And we can see that generative AI is here, and responsible AI here is also indicating that they have larger impact and also sooner impact. So there's a very nice study showing us how AI and generative AI are very important technologies. And also another report from McKinsey about the economic potential of generative AI across different industries, including high-tech, banking, telecommunications, healthcare, insurance, and even agriculture, energy, real estate, and so on. We can see there is expected high impact for generative AI across different industries and across also different rules and functionalities, including, of course, the software industry. So we can conclude that AI and the generative AI are expected to have very big potential during the very, very sooner time. So today we're going to talk about what is AI, what is generative AI. We're going to talk about some examples of generating images using GANs and diffusion models, and how to have chatbots using language models, how to do prompt engineering, how to ask and chat with your own data, and of course some advanced topics including extend the language model with tools, long context window language models, AI agentic workflows, and so on. So what is machine learning? Machine learning is basically learning from data. So if you know the rules, you just write your program. However, if you don't know the rules, you can inspect the rules or learn the rules from data. So for example, if I give you this data, this is like the house area, and this is the price of the house. And what you can do with this data, of course, you can fit some sort of a model. We can choose a very simple model like as simple as y equals ax plus b, and try to find the best values for a and b to represent this kind of data. And this is called the training process. Once we have the model, we can use the model to make predictions. So if we have a new data point, we can just apply to our model and get a prediction. And of course, this prediction is our best guess given the data and the assumed model we have trained the data on. And of course, this prediction doesn't have to be 100% correct, but this is our best guess given the data. This is a basic idea of learning from data, or the machine learning. And of course, in real life situations, we don't have very simple models like this with two parameters like A and B. Usually we have like millions or billions of parameters. But the idea is still the same. We have data, we train a model, and then we can make predictions. This is the basic idea behind machine learning. So what about generative AI? Actually, as we have seen, any machine learning can be seen as y equals f of x. It's like a function. Your x is your input. Can be the house area, can be the pixels of an image, can be anything. And the function can be as simple as y equals x plus b, or even something much more complicated like a neural network. And the output here is your target. If your target is as simple as a number or classification or whatever, this is called the non-generative AI or the classical AI. However, if your output is in terms of some content that can be generated using some sort of a human, can generate images, can generate text, can generate audio, this is a generative AI. So AI or machine learning as a specific part of AI is as simple as y equals f of x, and depends on the kind of y, whether it is generative or not. There are many examples actually for today and tomorrow for generative AI. For example, you can give your model some sort of text and it will generate an image for you. Like these examples from well-known companies, of course, like Google, OpenAI, Microsoft, and others. And also given a text, you can generate video, or you can generate 3D objects, or even you can ask questions. For example, what is the girl on the left is holding in her hands? And you can also generate source code, and you can have conversations including text and images and so on. These are just samples of and use cases of generative AI. Very good. But when it is safe actually to use generative AI, this is a very nice guidelines from UNESCO about when it is safe to use ChatGPT, for example, for higher education. So the idea is very simple. Do you care about the answer, whether it is correct or not correct? Of course, if you care about the answer, do you have the skills and experience to judge the answer or challenge the answer? And if you have this expertise, can you are you be able to willing to take the full responsibility of the output of the generated output? If the answers for these questions is yes and yes and yes, then it is can be safe to use generative AI. Of course, generative AI is expected to increase our productivity, creativity, can support us, and so on. But take care sometimes, like us as humans who are learning from data, learning from examples. Sometimes these models can be biased, can give you inaccurate data, hallucinations, can be used for unsafe usage, and so on. Very good. Now we know what is machine learning, what is AI, what is generative AI. Let's move on for a practical example, which is generative adversarial networks, or GANs. If I ask you for these faces, some of these faces are real for real persons, and some other faces are fake, generated somehow using AI. If you have this question, you try to find which is real and which is fake, try to find artifacts. I mean by artifacts, something that is not usual, not natural. For example, like this part here. So my guess, my opinion is that this image number 6 most probably a generated face. It is fake face, not for a real person. And if we keep looking for artifacts, you can see number 5 can be also fake. Number 4, number 1. This is my opinion. Of course, this is subjective, may differ from someone to another. And for me, I failed to find artifacts in these two images. But as you probably know, all of these images are actually fake. They are generated somehow. There is a nice website. It's called thispersondoesnotexist.com, and every time you refresh, it will generate for you a random face for someone who does not exist. So how can we do this? This is called the GANs, or Generative Adversarial Networks, invented by Ian Goodfellow 2014. And the basic idea is very simple. This kind of network just to see lots of data, understand their distributions, and then they can hallucinate or imagine similar data. And Ian Lecoq mentioned that at that time, this is the most interesting idea in the last 10 years. And we can see that since 2014, 2018, and beyond, how the quality of generated faces are getting better and better in a very short period. So how GANs are trained? It is actually very tricky. Usually we have two networks. So the first one is called the generator, the network that is responsible for generating, hopefully, very, very realistic images, and another network called the discriminator. This network is trying to distinguish between the two, the real images and the fake images. The two networks are trained together until they find some sort of equilibrium point where the generator can generate really good images, and the discriminator cannot distinguish which is real and which is fake. And after the training, we just use the generator network to generate images, as we have seen. There are many applications of GANs and the nice papers, including this one, very well-known paper, Style GAN. You can see that we can generate image for this gentleman and an image for this lady, and we can interpolate even between these two images together. And the good thing about this network is that the interpolation is very smooth and also without artifacts most of the time. And also we can have these nice animations starting from a face and moving to another one. And it is not only about faces. Of course, you can generate any kind of data like vehicles and so on. Another nice application is called the image-to-image translation. You can train your GAN to translate from day to night or from winter to summer and so on. And accordingly, if you wanted to collect a lot of data, you don't have to collect physical data all the time, but instead you can just translate from one domain to the other. And this, of course, saves a lot of time and a lot of effort. And you can train your models accordingly, not only in real data, but maybe a mixture between real data and the generated data. So if I give you this image and ask you, can you imagine this image at night? Or I give you this image and ask you, can you imagine this image at the summertime? If you can do it, we can train a network to do it also in an automatic way. Another also related example, you can train a network to imagine an image without rain. It's called deraining. Of course, this is a very nice application. Another one is called in-painting. If some part of the image is missing, like this part of the dog here, the network can be trained to imagine the missing parts. These are just examples of GANs, how it is trained, how it is used in different applications. And there are, I would say, not tens, but even hundreds of well-known applications and different variants of GANs. And one comment about GANs, it's a little bit tricky to train a GAN because two networks are competing with each other is a little bit tricky and not easy most of the time. However, GANs are very, very important in the generative AI field. More recently, we have what's called diffusion models, also for generative AI to generate different kinds of data, including images. The idea of diffusion model, in my opinion, is simpler than GANs. If you have an image, you can add noise gradually to the image until you have total noise, and then you can try to remove the noise from the image. You try to reverse this operation, and this is a diffusion model trained to denoise gradually, step by step, these images. So you can start from noise, end up with a very good image. So a very quick comparison between GANs and diffusion models. GANs are fast because you just give it an input and give you a generated image. However, diffusion models are slow because we mentioned that you need to remove the noise step by step. So you need maybe like 50 steps, 10 steps, 100 steps, it depends. However, GANs are a little bit harder to control and it is tricky for training. However, diffusion models are easier to control. So this is why usually diffusion models give you much higher quality of images, and it's easy also to control and easier to train. Here are very well-known models based on diffusion models from OpenAI, Google, and Stability AI. And you can see the quality of the image and the controllability of the images. For example, one of the open access models and the open source models, I believe it's called the Stable Diffusion from Stability AI. If you go to this website, you can write here whatever you want it to be generated. You can write here something like a paragraph about what you wanted to generate, and you can control also the style of the generation, and you can get something nice like this, the Great Pyramids of Egypt. You can change the style, and you can get something also like this. And here I tried different examples. For example, here I said that the Great Pyramids of Egypt, a majestic view, and so on. And here the input text was a cute ancient Egyptian princess wearing a hijab or something like this. Actually, again, like GANs, diffusion models are very, very hot topic as we speak. And there are many, many applications for diffusion models to generate 3D motion, videos, audio from text, and even time series forecasting, and many, many other applications. So we have seen that these models can be controlled using language. So how the AI can understand languages? This is called large language models. So what is a language model? Actually, all of us have been using language models for a long time. Language model is something that can predict the next word. So in your keyboard, you write something like, I will watch A, and the keyboard will the software actually will propose for you these three words. So if you have something that can predict the most probable next words given the context, this is a language model. And there are many kinds of approaches to implement such thing. And of course, one of them is using deep learning and neural networks. So a simple definition for a language model is a model that can predict the word comes next. So for example, the students open there. I think we all agree that books is a proper word, laptops maybe, but cars, neural networks, office, not that proper. So this is again a language model. Given the context, this is your language model, give you some sort of probability distribution over the vocabulary. So we have high probability of books, a little bit lower probability for laptops, and much lower probability for other words. Language model is actually a very important component across many applications. So these language models can generate words conditioned on some input. If the input is audio, So this is a speech recognition. If the input is another text to be translated from language to language, like from Arabic to English or whatever, this is called text translation. If the input is summarization or long text need to be summarized, this is summarization application. If the input is image, this can be image captioning or image description or OCR application. So again, language model is something that can predict the next word and can be conditioned on some input. And depending on the input, we have many different use cases across different applications. Currently, we have what's called the large language models. These language models are, as we can see, according to this timeline, from many companies. You can see from Google, DeepMind, Microsoft, Salesforce, OpenAI, and many others. And some of these models are available. Some others you have to pay to access these models. Some models are small, like 1 billion parameter or 10 billion parameters. Some models are like hundreds of billions of parameters. Some models are trained on natural languages. Some models are trained on natural languages and the programming languages and so on. So this is just to give you a survey and the landscape of different language models seen in the last few couple of years or something. So if you wanted to explore these language models and try them across different tasks, whether the task is related to natural language processing, like summarization, translation, or whatever, or computer vision, like object detection, and so on, or even multimodal that includes text understanding and image understanding, you can go to the Hugging Face website. It's a very nice website with many models you can explore from many providers. And if you like a model of these models, you can read about the model. For example, this is a very well-known model called the Llama 2. It's from Meta AI, and it comes with three sizes: 7 billion parameters, 13 billion parameters, 70 billion parameters. Of course, the larger of the size indicates better model. However, it may cost you more in terms of computation and memory and so on. And even though from this website, Hugging Face, you can explore and search, you can read and understand, and also you can try the model. For example, here I selected the Llama 2 with 13 billion parameter, and I asked the model as ChatGPT, define very shortly what is generative AI, and give me very nice description. So, language models are very nice. They can understand the text, they can answer questions, but they are not mind readers. This is why we need something called, prompt engineering. Prompt engineering is a process of designing the prompts or the text input for a language model to generate the required output. If you are someone who can explain, who can elaborate, who can give examples, this is good for you to communicate with your colleagues. And also it is good for you to communicate with language models. And of course, the quality of your input text determines the quality of the output of the model. Here is an example to show you how the prompt should be, for example, constructed. You have to give some sort of context. I am a software developer and should be specific, working on a Python project, for example. And my goal is to, please, can you explain for me how to handle exception in Python? And the output, please format the output in this way. This is just an example of a good prompt. I'm not saying this is a perfect prompt, but this is a good prompt because we have all these items represented. So instead of asking your model directly a question, it is much better to be more specific, give the context, control the output format, and so on. And here is another example of prompt used for DALL-E 3, another model that you can give it text and it can generate for you nice images like this one. And you can see the more you put details in the prompt, the better you can control, of course, your output. You can see the yellow banana-shaped couch, wooden floor, rug, and also plant here in the corner, the sunlight from the window, and so on. So this is just another example how the prompt should be written in such a detail and to be very specific to have better results and more controlled results. Usually, let's give you, it's very important for prompt engineering, for example, to give your model some solved examples. Let's have this use case. Consider that you are building some sort of sentiment analysis application. You are collecting feedback from your customers for your products and services and so on. And you want your model to classify the feedback, whether it is positive or negative or neutral. Before language models, you have to build your data yourself. You have to collect lots of data and you build your classifier and so on. Thanks to the pre-trained language models, all you need to know or to do is to ask your model directly, please classify the next text to be positive or neutral or negative. That's it. And in most cases, the model will answer with you with the correct answer. However, it is much better to give your model some examples. You know, my model, please classify the following into neutral or negative or positive, knowing that this example is negative, this example is positive, and so on. So this is like you are communicating again with your colleague. You can give him the task, or you can give him the task with some solved examples. It will help the model to understand what to do. Very good. What else? Not only give your model solved examples, but also give the model the steps of the solution. For example, here we have this puzzle, a little complicated one, and this is a direct answer. And this is another puzzle, and there is a high chance that the model will not answer correctly. However, like what you do with your colleagues and the friends, you give him the puzzle and the steps of the solution. Then the model will understand that, given this prompt, this kind of questions should be answered step by step, because you gave me example with a step-by-step answer. In this case, you are increasing your chances to have better results. I know this looks trivial, but surprisingly, it works with the model. Models can understand the examples, can understand the intermediate steps and reasoning steps you give to the model, and it can generalize to your questions. And this is called the chain of thoughts, a very well-known paper. Another very nice paper, it's called the emotional prompting. It has been found that if you ask your model a direct question, it will give you an answer. However, if you tell your model that this is very important to my career, or you would better be sure, or something like this, usually your model gives better results. We know that models have no feelings, but because these models are trained on massive amount of data, usually from our chats, news, and so on, so it was found that these models actually can give better results if you talk to your model as if they understand emotions. And this is also another paper. Actually, the area of prompt engineering is very, very important area, underestimated area, in my opinion. However, it is very, very important. And this repo provide for you many, many resources and examples and use cases for prompt engineering. Very well. Now we understand GANs, we understand diffusion models for generating images, and now we understand what is a language model and what is prompt engineering. Let's see a very nice use case, how to ask or chat with your own data. Usually, models are trained on their own data. But if you ask the model a question about some data it never seen before, it will not answer. So the question is how to enable a model to answer given my own data that the model didn't see at training time. We can do this using what's called RAG, or Retrieval Augmented Generation, to enable the model to answer given external resources. And the idea is very simple. Let's imagine you have your own data in terms of databases or PDF files or whatever. You take your data and divide it into splits. Each split could be a page or paragraph or whatever, according to your case, and store your data in what is called the vector store. And this is like ingestion phase or indexing phase. At deployment time, your user will ask a question, and given the question, we will find similar splits or similar pages in the vector store, and then ask the model, please, you are an expert in whatever area, try to answer this question only given these retrieved splits. Now the model will give an answer not based on its training data, but actually based on the extracted parts from your own data. This is a simple idea of RAG, or Retrieval Augmented Generation to enable your model to access external knowledge sources instead of its internal training data. This nice and fancy pipeline can actually be implemented in just a few lines of code thanks to LangChain framework. So here you can load your data. It can be text, PDF, or many different formats. And then you can do the chunking, do the embedding, store your database, and that's it. And then given the question, you pass the question to this chain and you get the answer.
Can I ask something, please?
Sure.
According to the figure in the corner, yes, retrieval means something that exists in the data set, not something new, but
Yes, exactly.
generative means something new.
I will give you an example right away. Okay,
yes,
I will
please.
choose. Okay, very good. Thank you very much.
Thank you.
Here is the example. Okay, so in this example, I built this website in like 5 minutes, thanks to Streamlit, and I implemented this exact pipeline. So here I browse and I upload a PDF file, and this was one of our papers published recently, like 10 pages or whatever. And here I ask a question. So what happens? This paper is divided into sections, and based on my question, the system retrieves only the sections or parts or paragraphs related to my question, and the model is given this task. Please, given this 3 paragraphs, for example, try to answer this question. So the generation is based only on the retrieved parts related to the question, and it gives me the answer here. So this is a basic idea of the pipeline. I hope I answered your question. So in this way, using the prompt, I'm enforcing the language model to summarize or extract answer from the retrieved part related to the question. If I remove this part, the language model will answer the question based on its own internal information during the training time.
But in the example of generation of fake images, it's a new image, not existed before.
This is something. Yes. This is something totally different. In GANs, I'm generating totally new imagined image. However, here I can ask a question and the model can give me an answer like ChatGPT. What
So
I'm telling you,
yes, it's a
this
variety of applications, not
exactly.
Yes.
Exactly. Here
Yes.
I'm enforcing the model not to imagine. I'm enforcing the model to imagine the answer given the context retrieved from the data.
Yes, but we saw examples of ChatGPT answers to questions, and it was wrong.
Hallucinating answers. Yes. This is what
Yes.
I'm saying. If you wanted to enforce your model to give answers from a predefined set of data set, you can use what is called RAG. This is the idea.
Okay.
How
Excuse me.
to reduce.
Last. Yes.
Sure.
Okay. I'm asking about the data sets that ChatGPT or LLM or whatever trained on it. It's not public, and we don't know about it.
Very good. Very good.
So
Okay.
how to customize our research or applications or
Okay.
to our own data sets?
Some models, especially commercial models, they don't tell you what kind of data sets and even what kind of training procedures they used or even what kind of architectures they used,
Yes.
like OpenAI and others. However,
Yes.
there are many open source models. So they tell you what kind of data they are trained on and so on. For example, like Mistral, for example, Llama and others.
Yes.
So there are two sides of this game. There are closed models and there are open models.
Yes.
So usually we don't start from scratch. We don't start the training from scratch. Usually you get some pre-trained model, generic model, and you can fine-tune the model according to your needs, or you can use tricks like prompt engineering or RAG or whatever.
Okay. Thank you.
Hello, Mr. Ibrahim. I want to ask you some question.
Sure.
So you talk about generative AI. It's unsupervised learning, right?
Yes, in most cases it is unsupervised because
That's
at,
how
at,
to
at the end
grade.
at the end of the day you have to have some sort of learning signal. So for example, you train your model to predict the next word, so you give it
Yes, I
text like
wanna confusion in this.
yeah.
How discriminator, how generator generate image on the data he didn't have the label on it. So how you specify that image is for the faces and other for the car and other for other
No,
things?
it knows. I mean by okay, very good question. I mean by it is unsupervised. I mean you don't have someone to annotate the data, but you have a folder with real images and you have a
Oh,
network
label.
that generate. So there is no
Yes.
label, but again, there is some sort of learning signal because now you know this image is coming from
Metadata?
your. I'm trying to answer you. This discriminator knows if the image is coming from real data or coming from the generator, which is fake data. So
Yes,
this is
yes.
this is the point. But there is no person come and try to annotate the data. This is why it is can be called as unsupervised learning. You
It's
don't
just
need
to generate.
someone. Yes.
But what's the base of generating the image and what's the rules of generating the image?
No rules. This is what I mentioned. Both networks
Like
are
augmentation
no. These two networks
or
are random. These two networks are randomly initialized. Okay, they don't know anything in the beginning. Of course, the generator is just generating some sort of noise, and the discriminator doesn't know which is real and which is fake. And through the learning process, the objective of the discriminator is to discriminate between what's good and what's bad.
yes,
Sorry,
yes.
what's real and what's fake. And the objective of the generator is to fool the discriminator. And this is why this training is not easy to apply. This is a basic
I
idea.
know what's the architecture of generative network. He used CNN. I know, but يعني, I how he generates the image. He have a data unstructured. Yes. So the data is specific for category or one category or in general.
No categories. It doesn't know anything about any categories. It
How
is
we
like
predict, how we generate.
it. What do you mean by how to generate? It generates based on the objective function for the network. This objective function, this is like a binary classifier. It has binary cross entropy. This is like a usual classifier, very simple classifier. And this one, the objective function, when we are training this one, we fix the parameters of this network and we try to fool this network. So we wanted to tell the
I
network
will my
everything.
question more clarified. What's the pipeline of the model in generator? So, the architecture and the pipeline, or something CNN. We know we do some sort of padding and other layer. And what's the difference in generator network from it and CNN? What's the core difference?
The generator network takes a random number or random vector, and the output of generator network is a shape. It's like width by height by 3, like RGB, if you are generating RGB image. So the output of generator network is actually an image in terms of width and the height of the image and the RGB of 3. This is the network architecture. So it takes a small vector and make it bigger and bigger and bigger until you get your width and the height by 3. This is the and of course it's based on convolution neural network. I think maybe we can have this discussion offline if you want, but the basic architecture of GANs is very well known, and there are many tutorials talking about this. I'm just giving you here a very high idea.
Is a fully connected layer is removed from generative model and
I
he
never say
just
there. I never said that there is a fully connected layers in the generator.
what
That what? There
or
is
why?
no fully connected layers because we don't need the fully connected layers in the generator. We just need only convolution.
I say we remove it. We just feature extractions feature of image or that. right? Or false?
The exact architecture of the generator is as follows. It takes something like 1 by 1, like one number. This is the simplest thing. And then it make it bigger to 2 by 2, then 3 by 3, then 10 by 10 until your final image size, which is 100 by 100 by 3, for example. Fully convolutional. Okay?
Okay. Thank you for listening.
Thank you. So let's continue. So we talked about many things actually. Okay, this is a prompt engineering. This is the example. And we talked about how to ask your data and how to enforce your model to answer from a specific external source of data, not from its knowledge. And here is another example. I also implemented the very easy. You can chat with your YouTube files. So you can enforce your model to give you answers from any source. And here in this example, you have YouTube. So you can put here your YouTube file or YouTube link. This is a very long file, like 2 hours, and they ask it a question. And again, it analyzes the file, it gets the text or transcription of the speech of the text, and it gives me a very nice answer with references from where you can get answers. So the idea is this, you can enforce your model to get answers and chat based on your own data, not from its own data, from your own data. And of course, there are many use cases. For example, you can build a chatbot for your customers to chat with your products and services and so on. Or you can have a chatbot for your teams internal in the company, your enterprise or company, to have chat with your internal data in terms of projects, marketing, docs, and so on. And you can have chatbots for your students to chat with your books, lecture notes, and so on. There are many, many use cases for chatbots for you, of course. So now the interesting part, the advanced part, how you can extend the language models. You can extend language models with tools. Usually language models are not very good for computations, for example. They are not good for giving you recent information about something and so on. So you can have what is called AI agent, and you can give the capability of your agent or model to select which tool to use. For example, it can use web search if you are asking about current events, or Wikipedia if you are asking about people or countries or whatever, or calculator or programming or whatever. You can empower your model with different tools. At runtime, given your question like this, how old Tom Cruise should be in 2050, given this question, the model can reason which kind of tool it should use. And here it's selected Wikipedia because you are apparently asking about someone. So it used Wikipedia to who is Tom Cruise, and it gets the answer. And it knows now the birth date of Tom Cruise. And now to continue your question and to answer your question, it used the calculator to make the difference between 2050 and the birthday of Tom Cruise, and the answer is 88. Enabling your model with tools is very, very powerful idea, because of course models are not perfect, and by giving it these tools, you are solving many issues that can be faced with using the models alone. And the smart thing is that based on your description, your textual description for tool, the model can select the best tool based on your question, and also it can select different tools and do some sort of planning until give you the answer. But this is actually what we do as humans. If I give you this question, you will search for Tom Cruise when he was born, and then make this calculation and then give the answer. And the model can also do this by using tools. What else? Something very powerful also called AI agentic workflows. So what if you have a very complex question, and as a human, you usually divide it into simple questions, and given the answers for these simple questions, you can get final answer, and then even you can use code to convert the answer into some sort of figure, pie chart, or something like this. This is an example. For example, I asked here a model, what are the longest and the shortest rivers in the world? So the model divided this complex questions into simple questions, and then formulated the final answer, and then pass this final answer to another node, another model, to generate source code for this answer to finally get this fine, nice graph. So the basic idea, instead of having one node, you can have different nodes that can speak to each other and can design whatever workflow you need according to use case for different scenarios. So now I'm not talking about a simple model, I'm talking about a flow of nodes, and each node can do different tasks, and you can design whatever scenario you want, like this one. What about a new thing called the large context window? Usually models can accept at a time something like 32K tokens or words for simplicity. But there are other models can take up to 1 million tokens. 1 million token, this means like you can give your model a whole book at once, like hundreds of pages or even few thousands of pages at once. And then you can ask the model your questions. So here I use the Gemini 1.5 Pro, recently released. I give it something like a whole book about multimodal deep learning, a very large book with almost 300 pages. And after feeding this model, this large book to the model, I can ask now the model very complex questions like summarize the whole book for me, or make comparison between two different concepts in the model, in the book. This comparison was not directly implemented or written in the book. But because the model understands the whole book at once, it can answer very complicated questions like comparisons and summarization and so on. And this can be done thanks to the very large context window models that can be fed with like hundreds or thousands of pages at once. What about multimodal models? Models that can understand images and understand text. Again, the Gemini 1.5 Pro is one example of these models. I give it this image, like JPEG or whatever format, and I told the model, please, can you translate the flow chart into a Python program so it understands this is a start, this is the inputs, this is a condition. It can understand this image and convert it into software or piece of code, as we can see. Of course, these models, again, can sometimes make mistakes, but this is, in my opinion, a very, very great capability. Another example, I give the model this image from the internet. This is like a JPEG image or whatever, or PNG image. And I started asking the model, what is the minimum industry is going to be affected by 5G, for example? And it told me it is agriculture with 200%. And what are the major 3 industries are affected by the 5G? So it knows these are the industries, and the first 3 are automotive, cloud services, and the manufacturing. And it gives me this answer with a very nice table output and so on. So actually, these models are very powerful. They can understand the images. They can answer questions about these images. Another model called GPT-4 Vision, you can give it an image like this and describe the landmark, and it will tell you this image most probably is taken from New York Times Square at New York City. Or you can give it a complicated PDF like this one, and you mark this red part, and you ask the model, what does this part of the poster highlights? So it understands the whole thing and the focus here and give you a nice description of what's happening here. Again, I'm emphasizing that these models can understand text, can understand images, and can answer questions for you. So that's it. This is my final slide. I want to tell you this is one thing to remember. According to Andrew Ng, of course, the well-known figure in deep learning and so on, he said that AI is a new electricity. So imagine the world before electricity and after electricity. And AI is actually transforming different industries as electricity did before. And I would say not only AI, but also generative AI that will be used by everyone across different use cases and industries. Thank you very much. I think I finished on time. And by the way, this image is generated by Copilot. I told please generate an image of a robot writing a thank you on a board. So this is a nice image, as we can see, and this is my LinkedIn. If you want to know more about AI, please follow me. Thank you very much.
Thank you.
I want to ask you some question, please. Mr. Ibrahim, I want to ask you some question, please.
Sure, go ahead.
Generative AI is unsupervised learning. He generates specific data but he don't have the label of it. So
Yes.
how is that related to clustering? How is that related to key means or this architecture? I don't get a relation
Okay.
without it on
Okay.
that.
I see that you are confused about this point. Okay, clustering
Yes,
and the key
yes.
means and the others, it means that you have some points in the space and you wanted to extract some sort of structure of this data, like clustering the data. So these points are near each other. So this is a cluster. These points are near each other. This is another cluster, and so on. So the key point here, you don't have labels for this data. No one, no person, no human did some sort of annotation of the data. The same for GANs. You give it a folder that like your brother or whatever. You show your brother many images of birds without any labels, just many images of birds. And then you ask your brother, okay, you have seen lots of birds. Please take a pencil and try to draw a bird. Your brother understands now the distribution of bird. A bird has this kind of wings, tail, head, and so on. So again, this means there is no manual annotation conducted in the data. This is why it is unsupervised. Okay? Because there is no
I
manual annotation,
understand
it is
this
unsupervised.
point. I have another question or another recommendation. What's the book you recommend to read in computer vision and data science, and including the advanced technique in real time?
There are books and there are other references.
The
If
name
you
of
want,
book.
okay, okay. There is a MIT book called Deep Learning. This is a very well-known book. It's open source. Called the Deep Learning, MIT Press, and one of the authors is Ian Goodfellow, the one who invented the GANs. And there are also very nice courses on Coursera for machine learning and deep learning and
Yes,
others.
already do ML and the first three courses in deep learning. So Zujan
And
is
there,
very interested from.
and there are also lectures from Stanford and MIT and others. And my
Yes, Andrew
advice
NG.
is Ando NG and Ricard Pathy and many others. So my recommendation is go for books, go for courses like Coursera, and also go for lectures from universities like Stanford and MIT and others.
So I want to ask you the last question as an expert, as a senior in artificial intelligence, and you work in value. So how I be suitable for the work in artificial intelligence, because it's very hard skills and you must learn a lot of more and keep the learning process and don't end it. Like Andrew NG say,
You you
he keep
you, you,
learning.
you answered the question actually. The basic idea you have to have very good foundations. You have to understand probability, information theory, linear algebra, and so on, and you have to conduct all these courses we mentioned from lectures or from courses and so on. And you have to hands on. You have to go for something like Kaggle and try to write your own code and compete with others and so on. And you have to keep learning all the time, and that depends on the market needs. The area is very big, as you mentioned. Maybe something related to natural language processing, maybe something to speech, maybe something related to computer vision, maybe something related to banking, to finance, to healthcare. It depends. So just keep learning, and you will find your chances, hopefully.
Okay.
So what's your opinion in Udacity computer vision nano degree? Is the last
You said
question. I'm sorry.
you said this. This is another last question, but
I'm so sorry. I need to get
anything.
experience.
I don't have a preferred course. Whatever. I can't tell you take this course. Okay, I can't tell you.
Yes, thank you so much.
It depends. It depends on your prerequisites. You have to read what are the prerequisites needed. Is it advanced course or not? It depends on you. You are the one who should select. There are many courses. You can select from Udacity. You can select from Coursera. It depends on you. The resources are there. It depends on you and your background and your prerequisite and so on.
Okay.
Okay.
Can I ask?
Thank you for listening to me.
Okay.
Most welcome. Most welcome.
Okay, Dr. Sobh. First of all, thank you very much for this presentation.
Thank you.
You declare the main terms in a simple way.
Thank
Okay.
you. Thank you very much.
I want to ask what are the research directions in this field, generative AI? As I think it depends mainly on tools and brands. يعني they don't depend on research or
No.
it's not an open
It's still open. No, of course it is
research
open.
field.
No, it's open actually research field, and there are many papers. All you need is to follow the right journals and right conferences. For me, for example, in this in my LinkedIn, every day I publish summary of 2 or 3 papers of recent papers. So it is very active area of research. There are many papers for language models, for GANs, for diffusion models, for open vocabulary computer vision, for speech.
But to use ChatGPT or OpenAI as a tool, not
Yes.
يعني الapplication is the main
You are
object,
talking.
not not
You are talking about 2 different things. The first thing is the application or use cases. Of course, you can have already pre-trained the model and you can use it whatever in your
yes.
case, in your use case in the industry. You can have your chatbot for your website. You can have your whatever generative image for whatever. This is
in the core of
this is one part. If you wanted to contribute in the algorithm, in your master, in your PhD, or your whatever, you can still do it. There are many papers published every day. You can do it in your master, you can do it in your PhD. So you have 2 options. You can use it for development and you can use it for research.
In the applications, people don't trust the results.
This is why
especially
exactly.
in applications deal with money or health or something like that.
Sure, you are 100% right, and this is why I mentioned take care. You have opportunities and you have threats. The opportunity, it may increase your productivity, creativity, and support. However, take care. It can give you hallucinations, it can be biased, it can be harmful, and so on.
Yes.
This is, you will not find AI system that is 100% all the time because it learns from data. It's like us. It's like us.
Yes.
If you are an expert in field, you can't be 100% right all the time. This is the same way of AI. However, even with some mistakes, even with some hallucinations, it is still, there is an opportunity to make the best of it, right?
Okay, thank you.
You're welcome.
Thank you, Dr. Sobh. It was very interesting. And thank you everyone for attending the tutorial. We will have a short break now and see you back here at 5:15.
Thank you, Dalia. Goodbye. Thank you, everyone.
Bye.